Good day, everyone, and welcome to today's SecurityBoulevard.com webinar. We're excited that you've joined us. Got a fascinating topic, certainly very topical with what's happening in software development, the kind of work that we're all doing these days. Our topic today is a simple alternative to Kubernetes, container orchestration with Nomad. But today's webinar is sponsored by HashiCorp. My name is Mitch Ashley. I'll serve as your host and moderator. I do want to cover a few housekeeping things before we get started. We are recording the webinar, and all participants will receive an email with a link to the recording as well as slides. So we'll get that information to you. Good news is you can just sit back and really absorb what we're talking about today and not have to take lots of detailed notes. Also, we're giving away 4 gift cards at the end of the webinar, so please stick around. We love questions, and we definitely want to entertain those during the webinar. So if you have a question at any time, put it into the questions tab of the GoToWebinar software, and we'll get to those probably about 2/3 of the way through our time together today. So let's move to our topic. Simple alternative to Kubernetes, container orchestration with Nomad. My great pleasure to introduce our speaker today, Lance Haig, is Regional Manager of Solutions Engineering with HashiCorp. So let's get right to it. I'll turn things over to Lance. Take it away.
My talk today. It's a privilege to come and talk to you, and I'm very grateful for the opportunity. And I'm hoping that everybody's had a good day so far. My talk is on a little bit of an introduction to HashiCorp Nomad, one of HashiCorp's tools that has been around a while, and I really enjoy using. A little bit about myself. My name is Lance Haig. I'm a Regional Manager of Solutions Engineering here in Germany, and I'm managing the Germany, Austria, and Switzerland teams with regards to solutions engineering. And I've been in the company about just short on 2 years now. Today's talk is going to be, this is a little bit of the journey we're going to be taking. It's why orchestration, why Nomad. And we have a little bit, excuse me, a technical overview, and then do a demonstration, which is a nice way to showcase some of the basic functionality of Nomad because of time constraints. And then hopefully we'll have some time for to discuss the differences between open source and enterprise. So why orchestration? As we all know, there's a big drive at the moment to have the applications we deploy Dockerized or automated in a big way for the DevOps environment, so that it's easy to deploy and quicker to deploy, and a repeatable process that makes lives easier for not only for the operators of the tooling or of the environment, but also the developers, because they know that what they create is then pushed into production and should function as such. One of those tools is Docker, Docker containers that is used. And as we all know, when you deploy or you create an application, we're using Docker, that's great, the application is packaged, but it doesn't necessarily mean that it's ready for the running in production, because when you're going from your development environment here, you created a Docker container, and then when you're going to production, there's a bunch of things that you have to consider and think about and plan and design and implement before you can actually deploy your application. And that there's a bunch of them on the right hand side. You can see monitoring, security, networking, federation, config changes, you know, who does what where, supervision, and then obviously the orchestration layer. And that's why one needs an orchestrator, because the orchestration layer can assist deploying this Docker container that you have into this environment and make it happen, make it run in a good way. One of the challenges that we've got is that not all applications are able to be Dockerized, and this is one of the things that I think Nomad solves really well. So then we'll go into the brings me on to my next topic, which is why Nomad. Now, Nomad differentiates itself. It can orchestrate containers, but it also can do other things as well. So the guiding principle behind Nomad is to orchestrate any application. Now, it's a really broad statement, but to be honest, when you think about it, the way that Nomad is created, it is designed, it is really a good fit for this scenario. So what the idea is to bring the modern deployment methodologies and orchestration methodologies to your containerized and your non-containerized applications. So that includes batch applications as well, because you want to be able to use that same methodology that you know and love, being able to deploy, do canary deployments, do blue-green deployments, do shuffle traffic between left and right, or shovel the amount of versions of a new software out, so that you can test these things in production. But then this also then allows it to be used for non-containerized applications, which is one of the key unique factors, I think, that is really good about Nomad. And it's simple and lightweight. It's a very small binary that you then can deploy in your on your current infrastructure. So you don't necessarily have to build a whole new infrastructure just to run this product on. You could run it if you have a bunch of Windows servers out there that are underutilized. You could put the Nomad agent on there and the console agent, or you don't have to, but you put the Nomad agent on there and you start it up, join a cluster, and suddenly, voila, you have a Nomad cluster running on your Windows infrastructure in your on your current servers. So, and then you could use that to deploy things like .NET applications or Java applications into those Windows machines. So it's actually quite a powerful scenario. And what it creates with the other feature that Nomad really wants to enhance is that you have a single workflow, no matter if you're deploying Java applications or containers. The workflow is exactly the same. You write your job spec file and you submit it to the servers, and it then gets deployed, whether no matter what, or a mixture of them too. You can do Docker and containers together. So that, speaking of the workflow, this is how the workflow would look like. A user would go out, write their job spec. They would then submit it to the server. Now the jobs get, then the server would go and analyze and knows where all the jobs are running and how full the jobs are. How full the environments are and the nodes are, and then decides, okay, fine, there's an empty spot on the server number 3 here, and it will go and deploy it on their client. Now, this is one methodology that Nomad uses, which is called bin packing, which it tries to put and deploy as much on one server as possible so that you make the most efficient use of your hardware that you currently have in your environment. But there's another way of doing it where you deploy it with spread, and that spread environment will allow you to then spread out your application. So you can make sure that if you deploy 15 of these virtual 15 instances of your application, you want them to be spread across the 3 servers. So you'd have 3 on each server, for example. So that allows you to create that a different deployment structure for your applications. Now it has a broad ecosystem, as you know. HashiCorp is quite well known, and with the plugin functionality and the infrastructure you need, you can actually use a lot of these ecosystem environments with Nomad. So, for example, we run on Windows, Mac, and Linux. We use Docker, Java, a bunch of things, bash files, scripts files. You can basically name it, you can run it. If you can run a command on a server, you can use it on Nomad and then use that deployment methodology. It integrates well with Vault and with Console, and also can deploy on infrastructures, for example, your local servers that you have already in your data center, or on VMware, or any of the major cloud providers out there, because you literally just need a operating system to deploy it on. And then obviously there's many ways of interacting with Nomad, obviously the CLI itself, but then you can use Terraform to deploy job files. You can use Jenkins, CSI, Circle CI, whatever. And there's a lot of other options like NVIDIA drivers. You could use GPUs to deploy GPUs and use GPU jobs to do HCP compute deployments as well. So, I mean, it's really powerful that you can plug into all these different environments. There's a bunch of public users, and I'm sure you're recognizing some of the names out there. SAP, Target, for example, Roblox are quite good, huge users of Nomad, and obviously Cloudflare use Nomad extensively within their environment. We've spoken to our customers. We did a bit of interviews and spoke to them and asked them how they use Nomad. And as you can see, there's 4 layers here where you've got the use cases that you use, the environments, the operational overheads and the application types. Now, Nomad's mainly used, as you can see there, quite across board between containers, Windows, and non-containerized applications. Budget-wise, you can have a really broad spectrum from low budget teams to high budget teams, because you could literally have one person running a huge cluster, because it doesn't cost a amount of money and effort to get it running. The environments are on-prem, IoT, edge, cloud. It's really across the broad spectrum of deployment methodologies and environments. And then obviously the use cases we see mostly in our customers are at the moment are services that are running things to do document signing, big batch jobs, those type of things as well, and some HCP work, and a little bit of machine learning AI stuff at the moment. What's an interesting to compare it a little bit to what Kubernetes does is that Kubernetes can Kubernetes is running basically just containerized, because that's where it's born and bred and really good at it's really good at doing that. The teams that you need, my experience building, talking to customers and working with customers, the ones that do deploy Kubernetes of any shape or form, you need a really medium to high budget teams to be able to run this, because there's quite a bit of investment that one has to do to make and run a Kubernetes cluster and keep it there and train the staff and so on. And then obviously the environments where it's mainly used is cloud, some on-prem, but very little, and edge. And then the use cases go for HCP computing, machine learning, big data, and like serviceless jobs. So you can see this is what, from our customers and prospects, what we've seen them use in the past. But what really interests me is that if you put these two together, and you can see that Nomad and Kubernetes work well as a team, to be honest, where Nomad can orchestrate all those jobs and systems that you can't put into Kubernetes, that just aren't a fit for them, but you could still use Nomad to run this and then orchestrate these environments. So you basically can do the rest of the systems with Nomad and do your very highly specialized containerized application deployments with Kubernetes. It's the same. As you can see, we fit really well together, and I think that's a really good visualization of how we've seen things work with our customers. So we'll move into a bit of a technical overview, and I apologize if I'm rushing, but I've got quite a few to get through before we go to the demo, and I'd need to have some time for that. So technical overview. The architecture is basically a single binary, like all the HashiCorp products. You can run it in server or in client mode, just depending on the configuration options. The typical Nomad deployment, well, my recommended that I would recommend to people, you can run without console. You can definitely run a Nomad without console. I think adding console in here is the value that console brings far outweighs the challenge of deploying it. And to be honest, it's not that challenging. I've got some Ansible scripts that I use to deploy this for myself into some hardware I've deployed on my Turing Pi, or if I do it in my deployments on Vagrant or in the cloud. You would have 3 servers. So you'd have your server agents, which are the ones that are your control plane, 3 to 5 of those, and then you have X number of agents, Nomad agents out there in the wild running, and we've got people with huge clusters running, Roblox being one. The nice thing about Nomad is that you could have a multi-region deployment where Nomad can be federated together, and you could have a management of your Nomad clusters through one pane of glass, which is quite easy. So you could, quite nice to have, I think, as an operator, you want to be able to see these things, but not only in operators, but also the people using the tool to be able to see where their jobs are running and how they're doing. And as you can see, you can join it and you get basically region forwarding. So if you submit a job in region 2, it'll get forward region 1, it'll go out and be deployed in region 1. And that for me is quite powerful, I think, and a differentiator for Nomad. The forming a cluster. So you can do a manual cluster forming if you look at this diagram or this slide here, and that you could do without console. You would literally just spin up the configuration. You would tell it these 3 servers are your other server members, and off it goes, and it'll go and configure itself as a cluster. And then the agents, you just point them in the config file to the server, and that would allow them to join the cluster and register themselves. They're ready to do some workloads. You could do automated clustering with console, which is why I mentioned console earlier, where if your console cluster is deployed, you just need to start the agent in whichever mode, server or client, and it will find the others and create the cluster, which is quite good. And then obviously we've got the opportunity in the cloud when you've got deploying the cloud to use the order join from the cloud scenario, where it uses metadata from the cloud to create clusters and clients. And so we'll move on to the demonstration. So as you can see here, I have a cluster predetermined, pre-deployed early on, running a Fabio, which is a small load balancer on the cloud here, and we've run a job where we have one Fabio load balancer on each server that we're running. If you look here, there's a topology view where you can see how your clusters are doing. You can see we've got two data centers. We've got EU West 2A and 2B, and there are more nodes in 2A than there are in 2B, which is just how my cluster deployed itself. And you can see how much RAM and CPU used, and then you can see which the jobs are CPU and RAM, what allocations are here, and how much of your cluster exists, and so on. So you can see your servers, how many servers you've got, how many volumes they have, and how many allocations are deployed. So we know there's just one because we've deployed that Fabio load balancer. And here's the servers, and you can see who's leaders and who's not, and so on and so forth. This optimize button is from Nomad's auto learning functionality to help you optimize your applications when to be able to say whether or not you are you need to rescale them, or they can be automatically scaled for you. And then you've got the job view again, as I said before. And then storage here is where you would be looking at the volumes that you would be that have been mounted into Nomad using the CSI plugins, so that you can then see who's using the volumes and where they're running. So that's quite great. So at the moment we've got Fabio deployed, and as you can see, we've got nothing deployed else in the cluster. And here we've got the Fabio endpoint for the cluster for once we deployed stuff. So how do we deploy something on this cluster? I want to bring in my console here. I want to show you, so we can do Nomad server members, and I can't spell. And you can see we've got three servers in the cluster as we've had before. What I want to highlight is that we had to export the address for the server using this command so that our Nomad client can interact with the server. And so yeah, so that's it. So we can see the server, so we can go Nomad job plan jobs web app.nomad, and it'll compare it against the server. And as we can see here above us, there's Fabio's there, and it's comparing the server to what's there, and it says we should be running at Nomad job run index 0 because that's the index that we haven't run anything. So let's run that. So now we're going to run it. So it knows the state that it wants to run against when it was there. So if we hit that job file, we should see very soon the jobs spinning up in the interface. There we go. And this web server is now deployed. It's healthy. Well, great. That's really fast. And if we look here, we go to our little server where we say, let's see, oh, here we are. We're on node 1197. So that's on its own. That's really great. What would be fun is if we could maybe deploy 2 more of these. So maybe we just deploy 1 for now. And so we're basically scaling this group. So it just literally scaled. So if we go back to Fabio now, we will see that there are 2 of the instances in Fabio, and there will be 50-50%. So 50% of the traffic will go to each one. So if we go back here and we go, come on, and we can see that it's passing the traffic between the different nodes, which is quite cool, I think. I mean, we could keep scaling it up. I mean, but there's 2 and 2, so we could go 2 and 3, for example, and that's really good. But that doesn't. I mean, that's what you'd expect, I suppose, from something that is an orchestrator of containers, being able to scale the jobs and do what they need to do. But the key thing we spoke about earlier was how does one, what does the job file look like, and you know, how does it, what is it, you know, what do you need to do to write your job file? So if you're familiar with other orchestration tools, this is one that we're using here, which is using HCL, Nomad's language, HashiCorp language here. And we stipulate and describe our job. So we've got, you know, where we want to deploy it, what the, you know, if we want scaling, we can go 1 to scaling is minimum 1, max 20. So that's where I was able to click on the button there to make it bigger. You've got the little application, the Docker application we're running. We pass in the port, so that's why we wanted to see the port, and then you would get the port and the IP of the server to show in the web page. And then we've got our resources here. We're using 500 CPU and 256 megabytes of memory, a little bit big, I suppose. It would be better to probably, and then here, this is the console checks to see whether or not the application is healthy or not. So the idea now is to probably, we want to, you know, see how easy it is to federate, to make a, you know, a bigger cluster out of this lot. So what we can do is we can go to our environment and do a merge or join the 2 clusters together. So what one would do is you would go to the one server. So let's just make sure. Here we go. I can't type. Let me just. There we go. And we're in the EU West, as you can see there in the region. We want to join the 2 clusters. So let's join our US cluster to the US cluster. And there we go. Clusters joined. As easy as that. And when you look at this, you can see that if I refresh the page, we've got EU West now, and there's a little button up here, this drop down, and now I can go here, I can see what? Here is the West region. We've got a Fabio server running there as well. And we've got, you know, the same topology. We're just running Fabio there, exactly the same kind of circuit set, different IP address. So you can see here the data center is different. It's EU West to A and B, not EU, US West, sorry. And then you've got some clients here as well. So it's looking really good, and same browser windows situation. So what we want to do now is we want to say, okay, fine, how about we stop this job, this web app, so we can go Nomad job stop web app, and if you want to, you know, you can stop it, and it will be stopped. As you can see there, it'll be the dashboard should refresh. Oh, there we go. The web app is dead. But if we want to get rid of it, it'll automatically be picked up by the garbage collector. But if we want to really make it happen immediately, we can just do a purge, and it will get rid of the application. So if we just click on the option here, you can see that it's been removed out of the cluster. And as you can see, if we go back here to US, there's nothing in the US, and there's nothing in EU. So let's deploy a multi-regional job. So we can go here, and we can go Nomad job run, and we can do jobs web app multi-region. But before we do that, I just want to show what's different in the multi-region job. If you can see here, we've got the web app, the normal web app, and we've got just data centers in there where we want to do it in one region. But when you want to deploy to multi-regions, you want to be able to say, okay, fine, there's this extra stanza in here that says a multi-region. We want to do max parallel 1 deployment. And then we want to do in region 2, sorry, the EU West region, we want to deploy 3. And in the EU and US West, we want to deploy another 3. So there should be 3 in each region. So the way we're going to do this is we will go into this, as I said before, we hit the button, Nomad job run, and successfully I've now deployed the job here. As you can see, we've got the multi-region job running here. But if we go to our jobs here in it's also here and says dead. That's not necessarily a bad thing. Oh, it's just come out. I spoke too long. Basically, it was waiting for the deployment here in the region out here in the EU to deploy first and be up and running and healthy, and so that then they could do a deploy in this region here in the US. So if we look here, we can see that we've got we should have just 1 deployment over there, and we've got our application quite happily sitting here just feeding us 1. And if we look at this one over here, we should have a 1 deployment here, and we have our application running there. Now, yeah, I think that's really short, sweet, to the point, and it allows you to see that you can deploy really easily with Nomad, and it's quite easy. So if we go back, if we go to the last part of my slide deck, we will see that we have some options here between the open source and enterprise. So here's the different feature set. In open source, you've got service and batch scheduling, task drivers, device plugins, multi-upgrade strategies, those type of things, auto scaling, federation. You can do CSI, CNI again, web UI, console integration, Vault integration, namespaces. And then obviously the enterprise stuff comes with stuff. I mean, HashiCorp has to sell something, I suppose. Automated upgrades, automated backup, enhanced read scalability, redundancy zones, multi-vault namespaces, multi-cluster deployment, dynamic application sizing, and that's where that recommendations was there, where you would be, your applications would be monitored by Nomad, and then once happy that this is running and it's and understanding what's there, it will then make recommendations whether or not to rescale it. You can hit the button manually, or you can do it dynamically, where the system will automatically tune your applications to make sure that they can run at the most efficient manner. Then you get resource quotas, cross namespace queries. So you can have namespaces, obviously, like you have in Kubernetes, for example, and then you can query across them. So you can run one command to query and find that job that's misbehaving or not misbehaving, or just can't find it. You've got audit logging, and then obviously Sentinel, our policy enforcement tool, or the policy enforcement tool from HashiCorp. And with that, I want to say thank you very much for listening to me and the speed read that I did for you. And I hope that you have enough, and I'm looking forward to the questions, actually. Thank you very much for your time, and I'll pause now.
All right, fantastic job. Yeah, let's turn on our webcams here, get a chance to see each other as we field some of this great presentation, great talk, and appreciate the demonstration too. Really put some meat on the bone, give a real idea of what it takes, and it looks very straightforward, and it looks like you've done a nice job of kind of keeping to the core of it without sometimes the extra things get in the way, right? And the job you're trying to get done. So kudos on that. Let's jump to some of our audience questions. We've got some really great ones that have popped up from folks that are attending here. So let's start with kind of a couple to choose from here. Why don't we start with, just tell us a little bit about Nomad in the context of Kubernetes. And I think that's going to be a question this person asks, is going to be on everybody's mind of, well, Kubernetes is everywhere. Shouldn't we always use it? Why would I use it? When should I use Nomad? Why would I use it instead of Kubernetes? What are the trade-offs? Why do I do one versus the other?
Yeah, I think that's a really great question, because it's one of the ones that I think we field quite a bit. From my perspective, it's not really a one or the other scenario. They're not really competitive to each other. They're complementary. As I mentioned in the slides, Nomad can do orchestration, but then in addition to that, it can run jobs, your EXCs on Windows, do the same type of deployment methodology, your canary deployments for a binary that you're running on Windows as well. So it's kind of like a different way of doing things, but it's not a replacement for Kubernetes. I mean, a lot of companies deployed Kubernetes because they wanted that ease of use of the platform that would orchestrate for them and make their developers much easier and happier. But in hindsight, some customers I've worked with in previous lives before HashiCorp deployed Kubernetes because that's what they wanted, but what they needed was Nomad. They wanted just to automate their current infrastructure because they are very on-premise, or they have really strict guidelines about who can run what where. And so it's easier for them to deploy something that is easy for you don't need to train your staff or your engineering people, your operations people on this whole new methodology of how to do things. It's just another binary they run, and when they log on, they can use the same tooling they have now to log onto their systems and manage it. So it becomes a lot more easier to run it, I would say, and use it as a developer.
Yeah, that's very consistent with kind of what I hear from developers and teams is Kubernetes can be, it's great technologies, but it can be a little bit daunting at first to get it set up. There's a lot of things in Kubernetes and clusters and how you set it up to management. And, maybe complex is the right word, maybe it's not, but it sounds like when you don't need, the Swiss Army knife, you only need a blade and the scissors. You could sort of take the Nomad approach in those situations. Is that a good characterization?
I would say yes. I think complexity is in the eye of the beholder, I suppose. Some people would say Kubernetes is not complex to run because they understand it. Yeah. But if you think about you've got a person who starts out and wants to do something for their teams, the time to cluster, we call it. Your time to cluster is really short with the Nomad deployment. You would literally, you're still using, you have instances, you already have the networking configured, you already have everything in your system, and all you have to do is roll out this binary, tell it it's a server or a client, and there we go. You've got a cluster, and then you can manage it that way. And it's all sandboxed and things like that. So yeah, there's swings and roundabouts. I'm in no way trying to say that you should replace all your Kubernetes with Nomad. That's not at all what we're saying. I mean, the idea behind Nomad is more around use those jobs that you can't do with Kubernetes, but you want to use the same methodology that you use for your Kubernetes deployments. You can run that with Nomad as well.
Perfect, great. There's some questions that we had during your talk, asking you to clarify the different ways that you can use Nomad. And I think one of the figures showed Terraform and Jenkins and kind of the roles that they might play with working with Nomad.
Yeah, I mean, Terraform, for example, you could use Terraform to deploy your Nomad cluster, which you would obviously, most people do anyway. Or you could use Terraform to deploy jobs into the Nomad cluster. So there's an ability to write your job spec file and then have use your current Terraform deployment methodology to just push that job. There is a Nomad provider that you can then push the job into Nomad and let the Terraform manage your Nomad jobs in that respect. But you could also, because Nomad has an API, all our products, every HashiCorp product has an API interface. You could use your Circle CI API calls from from your Circle CI, your pipelines, any of the, to be honest, I mentioned Circle CI, but any of the automation CI/CD pipelines, you could use that to just call the API and submit the jobs via the API as well. So it's very API driven. So there's a lot of things that one could do to interact and push stuff to Nomad. And then obviously we use GPUs a lot. A lot of customers use GPUs for those big number crunching situations where you can push your jobs into there. Nomad's been recently, the new last 2 or 3 versions, we've added the CNI and CSI from the computer. From that's exactly the same drivers you would use for Kubernetes, for example, for your container networking interface or your container storage interface.
And that makes it easier for people who understand that to say, okay, fine, let me just connect this networking the way I know how to connect the networking kind of stuff. So you can sort of plug it in. Sometimes I use as a demonstration in other times how I'd use Nomad to deploy to Kubernetes. So I use Nomad to run the kubectl on a server to push it to Kubernetes. So it's both very flexible because, as I said in the talk, you have if you can run a script, you could run it with Nomad. So if it's something that you need to automate that's a script, you can run it with Nomad.
Very good. Okay. Excellent. I think it really puts some good context around it. Another question we have was about the security model within Nomad. They're asking about how you handle security. Can you talk about what is the security model? What things can you control? What things do you rely on, other software that you're using to do for you?
So Nomad has the concept similar to what Kubernetes has of namespaces and quotas for namespaces. Quotas come across from obviously the enterprise version. But by having those, you could use, Nomad has a concept of ACLs, access control lists, where the administrator would then activate the ACLs and have this overarching token. The administrator has an overarching token, ACL token, that manages a bunch of groups, as it were, namespaces that you could then say, generate ACL tokens for your developers, and that developer only has the ability to view jobs and submit them, but cannot delete jobs, for example, if you would want to do that for your developers. So it's a very, wouldn't say role-based access control because that's still on the pipeline, I think, but it's more around allowing you with your token to be able to do whatever you need to do. It's quite granular in this respect. You can only view the jobs. You can't do anything with them. You can just literally just query to say, hey, what's it doing? And what you would do that for mainly is when you have your CI/CD pipeline, submit the job for the developer can go in and have a look at the job and see what's the log files doing, how you can view it. You can log into the user interface via that. And then what's the other nice thing is that if you want the developer to be able to go and run commands on the console of a container, for example, they can click the button and get access to the container as you would if you were running the Docker command to get access to the container's operating system, for example.
I'd like to ask you about the APIs in particular. I mean, obviously, it's critical to incorporation into a DevOps tool chain. What are the ways that typical users of Nomad integrate it into the tool chain process? How do the APIs play into that?
It's basically the way that most people use this is to, at the end of their pipeline, would go through and do the normal, from a commit, would go and do the build of their package, get it into a state that they want to run it into a dev environment. Then the CI pipeline will reach out to the dev cluster and submit a job, where this job will go and fetch either the artifact itself, which could be the jar file, or it could be a shell script, or it could be your Docker container, run it on your dev environment, and expect a result back in that from the CI/CD pipeline. And then once it gets that result back from the dev environment, say, okay, fine, this is good, it's all green, let's carry on down the pipeline and then use the same thing again. So you wouldn't have a human interacting with the cluster at all. It would just be submitting jobs via the full API call. So you could what you can do in the UI and with the CLI, you can do with the API. There's no difference in what you can do in the different environments.
Tell me this, I'm perceiving this correct too. It sounds like this might be really handy for when you want to set up those own individual development environments, right? Using Vagrant, and so I'm not into the full team's pipeline, but I'm in my own workflow process. That it's going to be a little bit easier to set that up that way. Is that my understanding that correct?
Definitely. I mean, we use Vagrant. I mean, I have a Vagrant job file that I would run to set up a 3-node Nomad cluster, and then I have full access to, with 4-5 gigabytes of RAM in total in the cluster. I can then test my jobs, test whatever's going through there. That's how I do my demos, is mainly testing it in Vagrant before, because once it runs without the great thing about the portability of Nomad is if I've done it on my system, on my local system in, for example, Vagrant, it'll run anywhere. where you put it in, Google, Amazon, Alibaba, wherever, it can run.
That's right. So
it's the same API, and there's no kind of difference in respect to how it interfaces with the backend storage, or how it interfaces with. You will always have the same interface come to you for your job file. So when you register, for example, shared storage, external storage out of the cluster, it will always be registered in the same way. So you wouldn't have to change a job file. You would just say, hey, allocate this disk to this job, and off you go.
Mm-hmm. Excellent. Makes sense. While we're on this topic, can you just put things in context? HashiCorp has multiple products and multiple open source. Tell us a little bit about where Nomad fits into the sort of software stack of things.
That's an excellent question, because it's one of the things I think that's really great. All HashiCorp products work really well together, or you can use them apart from each other. You don't have to have one to run the other. They're all independent of each other. But we start with Terraform, who we all know and love, that to deploy the infrastructure. That's your infrastructure layer deployment methodology, and you can use that on any number of platforms. And then just above that, you would have your Vault, which is the secrets management tool, and Nomad interacts with Vault as well. It integrates as well, so you can share your secrets, get your secrets, create dynamic secrets from the Vault infrastructure side of things and the Vault service. And then the bit on top of that is where we've got the console product we have, which is kind of like a service mesh, service gateway, service discovery, all bundled into one big well, I wouldn't say big, one small binary, but it can do a lot of things. And this one allows you to connect all these things together and make sure you can load sidecars in Nomad. You can connect via sidecars across different clouds. If I'd had more time, I would have done the demo where I do a chat server where you put the web front end in the Americas and the backend database in the EU, and they can talk to each other without having a VPN, kind of using console. And then Nomad comes on top of that to be able to orchestrate all these things and make them play well together.
How about a question that we have from our participants here about stateful deployments? I'm assuming they're talking about things like Lambda and those kind of situations. Is this suitable for that environment? Or are there sort of any boundaries of min-max of where you do and don't want to apply it?
I would say it's really, if you store your state in a disk that you attach from outside, then you can do a stateful deployment on there, because the idea that you must always remember that the instances can disappear and go away. So if you have a server that you're running in your data center and it disappears, it's going to kill your stateful instance. But if you have it, you'll store your disk externally, you would be able to then have the stateful instance. We call it a service deployment, where you have a service running, and that's a standalone instance that gets deployed onto one machine, and that's where it will stay unless you tell it evacuate, so it has to go to a new one so you can upgrade. And the nice things about these deployments is that you can do an in-place upgrade of your client without having to bring your service down. So if you have to upgrade Nomad, for example, from version 12 to version 1, you would just do an in-place upgrade, a stop and start, and now you've got version 1 running. So that's quite powerful about that as well. But as you say, the caveat is that any stateful application in a cloud needs to have that extra bit of belts and buckles of storing your data somewhere where you know it's safe from failure.
And I guess my question wasn't a very well-formed one. I was equating Lambda to stateful. It's really stateless, serverless, and you could do, stateless in other ways too. But I know that's something that some applications are just architected that way. That you need to use a stateful kind of architecture. So yeah. That's something you certainly have accounted for with Nomad.
Yeah.
So let's talk about how many nodes are required for the smallest possible control plane.
The smallest possible control plane, if you're talking development, 1, your laptop, a binary. It runs as development, and it can run as a server and a client at the same time. So if you run Nomad Nomad-dev, you have a fully functional cluster, but in one single instance. A recommended minimum is 3 management plane and X number of clients, however many clients you want to put on that. but the management plane is 3. The minimum is 3. The max would be 5, I would say, in that. And you can get really large customers with those 5. That's the really large deployments.
And is that 3 for failover or load balance?
We use Raft as a kind of communication platform between the management team. So normally 3 is good for like any N+1 kind of failures. Raft is really good at recovering from these split brain scenarios. But so it's when you get into the bigger clusters that you want to be able to keep it down to be able to have that split brain scenario sorted out really quickly.
Are there any thoughts on sort of upper boundaries of how many clusters do you typically see? You would recommend in staying. This is kind of a good space to be. Just depends on.
Not really, actually. Not really. We've actually have a test we ran where we spun up 1 million containers in our environment across multiple clouds regions. There's a video of it, I think, or an explanation of what we did to get there. And that was a few years ago with Nomad. So Nomad's improved by this time. So I'm sure it'll be able to go bigger than that now. It's not. I don't think there's really a limit, an upper limit. It's just depending on how much you want to be able to see in that one pane of glass. You could, we've got use cases of people wanting to put Nomad clusters onto satellites so that people can manage their satellite operating systems via Nomad, which for me is quite a unique, interesting concept. If you think about it, that would be really cool. If you think about it, you could have your management plane running here on Earth, and you've got each of your Nomad nodes are out there as a single satellite, which would be quite cool for me. I mean, obviously, IoT is quite a big thing as well from us, where you can have these small clusters. I mean, my Turing Pi is as big as a A4 sheet, and you can run that's 7 servers with 7 gigabytes of RAM. So I think you've got enough to run a powerful little cluster in that one 12-volt battery connection.
I'm also thinking about, you and I were chatting a little bit before the webinar, developer relationships are so critical today. And I know you've performed in multiple roles throughout your career and also with HashiCorp. I'd love to hear your thoughts on HashiCorp's philosophy about developer relationships and how you best serve the developer community.
So from my perspective, the HashiCorp's whole kind of way of doing things is improving the workflow, making it the easiest workflow. If you're going to do something, it must be the easiest workflow. It should be the shortest, least painful way to get from point A to point B, from idea to running in production, for example. And the whole philosophy is think about how do we make this easier for the developers? How do they have to relearn stuff? Do they have to every time there's a change, do they have like a whole learning cycle having to go, or they just want to say, here, submit my job, and off it goes? And as you've seen, we've released recently, I don't know if you know, that we've released 2 new products, Waypoint and Boundary. This is again going to that journey of trying to make it as easy as possible for our developers to do what they need to do. Like the HashiCorp language is a common language across all of our products. So once you understand it in one product, when it gets to the next product, you go, oh yeah, this is the stanza, this is how you write this is what it needs. And you suddenly, you don't have to rethink yourself, you don't have to relearn everything. It's just different words for the same language. So I think that's the main philosophy, is about just keeping the workflow as simple and easy to do for anybody who needs to use the product.
Yeah, help keep people productive and not focusing on too much on the tools and the infrastructure, really on the job. And just to clarify for folks, Boundary, I believe, is about secure remote access, correctly?
That's correct.
Waypoint is about
application
workflow.
Yeah.
Okay, cool, excellent. Some other questions that we've had, and appreciate all the questions, great questions from the audience. They're fantastic. So feel free to, we've got a little bit of time here, we can handle some more. How does Nomad compare to the now defunct Docker Swarm? It's obviously container tech independent.
Yeah, I know Docker Swarm. I started using it some time ago, but never really got to use it in depth. Again, I think it's not quite the same. it performs the same function, if I would say that, same as it can spin up containers as Docker Swarm can do. I just think that it's a different role. I would say you could possibly replace Docker Swarm with a Nomad cluster because of the way Docker Swarm is also really easy challenge. What am I going to say? I've lost my train of thought now. It's really easy and it's not as challenging to set up as, for example, as some of the Kubernetes deployments would be. That's Docker Swarm, but it would still mean that you have to have a different way of interacting with the product, and the ease of use is probably a little less easy as it would be for Nomad, for example. But they are similar products, but we do different things. Yet the same. I don't know. It's very difficult because Nomad has this kind of almost does everything scenario, and it's quite true. If you can run it on a server, if you run the job on the server manually, you can do it with Nomad, basically.
Okay, very good. Does Nomad give any UI optimization jobs or any other way for developers? Anything on the UI optimization side?
Nothing. No, not for application. If we're talking about application UI optimization, no.
I assume that's what that is about.
Yeah. It's more about the optimizer in Nomad will look at what your resources your system is using, and because developers kind of over provision, they say, I want this super huge machine, but when you actually run it for a couple of months in production, you can see that you only need 200 megabytes of CPU or 200 gigahertz of CPU because the rest is just dead. It just sits there. And Nomad will make a recommendation, hey, there. Or if you want to automate it, it can reach out to the autoscale and say, hey, please automatically scale this resource usage down.
Great. Let me, if I might ask a question that I have, and that is for developers, folks that would seek out and look for a solution like Nomad. Where are they in their developer lifecycle, if you will, with tools? Are they kind of bump up against certain issues to say, I need something that solves this problem, or what would draw them to say, oh, I found Nomad is exactly what I'm looking for?
Again, I suppose it's just the ease of use, to be honest. There are, it's really the ease of use, because if you're a new developer and you're starting with wanting to deploy your application in the cloud, I mean, you could go to one of the, submit your code and forget about it jobs where you go like the Heroku kind of styles of things. But if you want that kind of control over your container or your jar file or whatever you're writing in Tomcat, you want that control of when it gets deployed and want to be able to update it really quickly and easily, just using the stuff you know. Because a lot of people, when you learn development, I myself are trying to learn Go at the moment. When you learn development, it's all local on your laptop. It's all stuff that you run locally, and then making that transition to go and make it run in Kubernetes and make sure that you've got your container working properly or whatever. Whereas with Nomad, you could just, that you've got to run the go run main, for example, and it will run, and you could just translate that into a script for Nomad to run and test and play with out on wherever you want to put it. So it's really easy to translate what you're doing as a beginner programmer to get your application out.
What was the term you used? Time to container, or time to, what was that?
Time to cluster.
Usually we talk about time to value, right? Time to cluster.
Time to cluster. Well, that's I think that's a catchphrase I use, is because it's so quick. You can have 4 people in a team manage a huge, I think the one at Roblox, which is really big mixed cluster between Windows and Linux nodes, I think there's 6 of them that run the whole of Roblox. It's huge, and you don't need that many cycles because it's quite easy once you've deployed it.
Well, good. And best place for folks to find out more if they want to get a hold of Nomad or the other products, visit the HashiCorp site. What would you recommend?
Yeah, there's a HashiCorp in general, the HashiCorp.com site, but then also each of the products have their own kind of web URL, and the one for Nomad is nomadproject.io. And we've got some really great learn guides that walks you through from not knowing anything to how to write job specifications and things like that. It's really step by step, no knowledge needed, kind of just walk your way through, download, run it on your laptop, and you're starting already.
I've seen on the site as well. Well, good. This has been fantastic, Lance. I appreciate it. Super informative, and I think, as I mentioned earlier, the demonstration kept it to the core knitting. What really does it take to get this up and running and be productive and kind of get to the job I'm really after, right? Which is getting my application going and out the door. So
I'm really grateful for the opportunity, and I really enjoyed it as well to speak about it. It's one of my favorite products. I think, well, the one I like the most. The challenge with the timing of the demo was because I just had a few minutes. If you have more time, you can show a lot more. Like there's an auto scaler that can scale out nodes for you automatically when you need them to scale out and scale back again. But those are all things that we didn't have time for today.
You don't get to show all the features of the car, but it sure drives nicely. That's what you need.
Yeah, exactly. Efficiently. Let's put it that way.
It's good power and gas efficiency. Just to use an analog here. Well, excellent, Lance. It's been a real pleasure doing this with you. I do want to announce our winners of our gift cards.
Awesome. Yes.
Unfortunately, we're not eligible to win, so we'll have to, let some other folks walk away with the good prizes today. So our 4 winners are Gabriel M, Scott L, Joe C, and Ray D. So all 4 of you will reach out to you, the folks here at MediaOps that helps put on this webinar for HashiCorp. Will reach out to you and let you know how you can get a hold of those and add that to your holiday shopping budget. So hopefully that'll help a little bit there. Just a reminder, we did recording this webinar, and we'll send an email with a link to the recording, so you can see those demonstrations, the demo and slides, etc. And we'll also have the slides, so you can look at those, and hopefully this has been a really good way for you to absorb some things about Nomad and HashiCorp and some of the other products that they have too. So Lance Haig, Regional Manager of Solutions Engineering for HashiCorp. Again, great job. Really have enjoyed doing this with you.
Thank you. I really appreciate it as well. Had a lot of fun.
Okay. It's been my pleasure hosting today. So wish you all the best. Good rest of your day. Be safe, be well, and let's be careful out there. Take care.
Take care.